Germany. These are a very delicate space processing facility here at Vandenberg where we process the spacecraft. You see them unloaded here on the multi-satellite dispenser, which allows them to be deployed at the same time from the launch vehicle.
All right, so throughout these events, we'll be hearing from the team, the SpaceX launch team, but the team itself will have certain communications that you'll be hearing on a special network with the team members. You're monitoring it. Sammy is monitoring it for communications. So we will be checking back with you throughout to get updates on the mission.
Sure.
All right, thanks, Sammy. Well, let's tell you a bit more about the mission now. It's called GRACE Follow-On because it's following in the footsteps of an innovative mission that lasted 15 years. It was called the Gravity Recovery and Climate Experiment, or GRACE. And GRACE revolutionized our understanding of how water moves around our planet. And GRACE Follow-On aims to keep the information coming and continue the legacy.
Water is one of the main indicators of how the planet is responding to our evolving climate. We built our civilization around the climate that we had and the water resources that we had. And if those are changing, that can have a profound impact on how we operate our society.
GRACE and GRACE Follow-On measure the motion of water around the Earth, and they measure that in all forms of water. Water that's stored underground, water in the ocean, water that's frozen in the form of glaciers. So all of that together, GRACE can measure.
GRACE Follow-On is a mission to measure how water is distributed on the planet and how that changes from month to month.
GRACE stands for Gravity Recovery and Climate Experiment.
And it's a follow-on mission to this mission called GRACE that we launched in 2002. And that mission just ended a few months ago, and GRACE Follow-On is going to pick up and continue that science legacy.
Even though GRACE flew for 15 years, climate is one of those things which takes place on decadal timescales. It's really important that we look at these trends over longer time periods so we can establish the forces which are driving them.
One follows the other, and between them they accurately track the distance between the two satellites. And as they fly over changes in mass on the Earth, they move back and forth. And we track those little changes very accurately. And we do that with global positioning system satellite information and with star cameras that are on board the two spacecraft. I think there's an increasing awareness and consciousness around the Earth that water is a critical resource and that the sea level is rising, the polar caps are melting, and that all these have long-term ramifications on how we live.
The GRACE Follow-On measurements give us very clear and tangible information so we can make sound decisions in the future of how we manage our resources.
Now, there wouldn't even be a GRACE Follow-On had the original mission not been such a game changer. With me now is Frank Webb. He's the project scientist for GRACE Follow-On. What exactly did we learn from GRACE?
So GRACE was very revolutionary in that it provided us with the first global comprehensive view of how our water system works, how our water cycle works in the globe. Of course, the water cycle is a very important component of our complex climate system.
So we have video of some of the things we saw over a 15-year period, and we can roll that video right now. Okay. What did you see here?
So in this map, we just seen sort of global water trends. And the water cycle is composed of many components, and that's water in different reservoirs on Earth. It's water locked up as ice, water in the ground as groundwater, water in the oceans and rivers, in the soil, in floodplains. And so with GRACE, we were able to, over 15 years, look at the trends in those water reservoirs and see whether they're gaining or losing water mass, essentially. And in this chart here, you can also see some of the big changes, such as in Greenland or Antarctica.
Let's talk about that. The big changes, the big surprises, or was that a surprise?
Well, so when GRACE was launched, we knew that mass moves and ice sheets in the oceans gain water or lose water. But we didn't know exactly how much was being lost. Even in Greenland, we didn't even know what the sign of the change was. So with GRACE, we were able to actually measure the amount of water that was being lost and what the rate was and where in Greenland it was being lost.
So here we have the video of that, of what you saw.
So in this video, you can see on the left there's a map of Greenland, and the browner colors show places where more mass has been lost from Greenland over the lifetime of GRACE. And you see there's a lot of ice being lost from southern Greenland. It gets browner and browner as the time series goes on. On the right, you see the plot of sort of the monthly changes. You can see sort of seasonal changes, but see overall there's a overall loss of mass in Greenland. And it's losing mass at about 281 gigatons of water each year.
And let's talk about that. A gigaton. I mean, give me, a layperson, an idea of how much water are we talking about?
Yeah, a gigaton's kind of a strange unit, but it's a mass unit. It's the amount of water that would fill a kilometer cube of a kilometer cube. So in this animation here, you just see a cube of water, a kilometer on each side. And we see here at the end, there's the Empire State Building for reference. So that's 1 gigaton. And now GRACE Follow-On showed, or GRACE, excuse me, GRACE showed that Greenland was losing 281 gigatons of water a year.
So 281 of those
Yes.
per year. All right, Frank, I'm sure you're excited about this moment. We're standing by. Thanks so much for joining us.
Thank you.
All right. Well, it is about 25 minutes past the hour. We are keeping our eye on the clock for 12:47 Pacific time. That is lunchtime. But meantime, let's talk about some quick facts about GRACE Follow-On. It is 27 minutes past the hour. Very soon now, we hope to get a status report on the satellites. We're having Sammy listen in for us on the team to find out some important information. Right around this period from T20 to T16 is kind of an important moment for the team, is it not?
It is. This is the time where we hear confirmation from the launch vehicle that the propellant loading is continuing. The liquid oxygen loading is initiated, and then also we hear confirmations and commitments from the launch team, from the GRACE Follow-On launch team, about the status of their system and readiness for launch.
So every minute or so for the next couple of minutes, you'll be hearing from people in the control room giving these status reports. Are these go for launches?
Correct. So every subsystem will report to the GRACE Follow-On project manager for the satellite, for the mission operations center and such, and they will report to him the status of availability of the assets that they have, the personnel, and the systems are all go for launch.
At about T20, I understand, is that usually the time where they decide to go to internal power? When they go to internal power, what does that mean?
So the spacecraft are now powered by, they're plugged into a power supply essentially, and at T20 they're given the order or the command to go to internal power, which means the spacecraft now will be disconnected from the external power, will be operating on their own internal battery power.
And then after that, that means
They're ready for launch. They're
this is
readiness
it.
for launch, correct.
Good to go. All right, so we are standing by. We should be getting that fairly
We
soon.
should be getting
wouldn't it?
confirmation very soon.
All right, and once we get these goes, the rocket itself and the spacecraft, everything is automated from this point on, is it not?
Correct, pretty much automated. There are, of course, notifications throughout. If there is any problem in the launch vehicle process, they have an ability to halt the launch, but we don't anticipate that at all. Everything has been nominal on every measurement that we've seen.
And have you heard any communications yet?
Not yet.
All
We'll get confirmation in just a second.
All right, so as we watch the rocket, we are standing by. All right, Sammy, we do have something now.
Correct. We just received confirmation that the spacecraft are green for and go for launch, and that the Mission Operations Center is green and go for launch. And that confirmation was provided to the launch vehicle.
All right, and we will be getting more?
We'll be getting a final confirmation from the launch vehicle at this point that they are ready for launch.
All right, okay, standing by for more. All right, Sammy, as we're standing by, one of the things about this particular launch, this is an instantaneous launch. What do we mean by that?
So in order to place the Iridium satellites in particular in the right orbital plane where they are actually inserted to complete a constellation, then there's a specific time that we must launch. Otherwise, we will have to spend a very large amount of propellant in order to get the satellites into the right place. And right now, it's an instantaneous launch for this occasion. In normal launches, if you do not have to insert the satellite into a constellation, you have a little more leeway. You have a little open window. But in this case, we have to get into the same slot.
So if we don't make that time, then we just scrub and turn around and do it again tomorrow?
If there is an issue and we are not able to make that time, then we'll have to scrub and go for tomorrow. Tomorrow will also be another instantaneous launch window.
All right. Standing by. As we wait for launch, NASA and the German Research Center for Geosciences share the responsibility for developing and launching GRACE Follow-On. For the mission operations, GFZ subcontracted the work to the German Space Agency, which operates the German Space Operations Center, GSOC, and it's outside of Munich, Germany. That is where much of the GRACE Follow-On team is right now, including systems engineer Neil Daya, who is with us via Skype. Hey, Neil.
Hey, Gay, how you doing?
I'm just fine. So tell people why so much of the team is out there in Germany.
Okay, a lot of the team is here because this is the center for where all the communications from the satellites are going to come down. We have ground stations all over the world, but this is the mission operations center. And so all the information is going to come down here. So we need experts around for all the different aspects of the spacecraft and mission control here.
All right. So can you describe to me who's in the room, the control room beneath you, and what are their jobs? How many people, how many teams are there?
Okay, well, we got a bunch of teams, but the overall people, as Sammy had said earlier, we have GFC, which is responsible for the mission operations, and the mission operations is here. As part of GFC's responsibility, GSOC and DLR are responsible for the flight operations, and this is their mission control room. So a lot of this room is staffed with the GSOC people. But then Airbus is responsible for doing the spacecraft, design, build, and testing of the spacecraft. So all their subsystem experts and their management are also here, and we've got enough people in here to staff 2 shifts. And then on top of that, we have JPL people that are responsible for the overall management. We have JPL for the instruments, and then we have our quality assurance people also.
All right. So, Neil, we will be checking back with you soon and with other members of the GSOC team. Thanks for joining us for right now. All right, JPL's Mike Meacham recently interviewed Neil on the unique design of the GRACE missions. Unlike most Earth-observing satellites which point their instruments towards our planet, the GRACE twin satellites work as one instrument that look at each other to see gravitational changes on the surface. You have to admit, it is some crazy engineering.
Here on Earth, we all know about gravity. But what you might not realize is that depending on where you are on the planet, the strength of gravity is different. For example, up here on a mountain with all this mass under me, gravity is stronger. Water also has mass. And the Earth has a whole lot of water, it's moving around, it's changing phases. If you can track the change in gravity, you can track the change in mass, and that means you're understanding the movement of water. NASA's about to send the GRACE Follow-On mission, which will continue to do just that. Let's learn about it on this episode of Crazy Engineering. Okay, everybody, we're here with Neil. He's one of the key engineers on the GRACE Follow-On mission. Neil, thank you so much for joining us and answering our questions. Why do we call it GRACE Follow-On?
So GRACE stands for Gravity Recovery and Climate Experiment. We're using gravity to track water motion around the planet. And the follow-on is because we've done this before and we're doing it again with 2 new satellites. The original GRACE mission was launched in 2002. They lasted for 15 years and provided amazing science for the scientists.
Both of these missions have 2 satellites. Can you explain to us why we need 2 satellites instead of just 1?
So we need 2 satellites because we're trying to measure very precise small amounts of gravity changes in the Earth. The Earth is actually lumpy when it comes to gravity. Far away from Earth, gravity is just a single number, but as you get closer to the Earth, the gravity changes because the Himalayas have a little bit more mass, certain areas have less mass. And so as a satellite is orbiting the planet, as it comes towards a large mass, like the mountains, it actually will speed up. And then as it leaves, it will slow down. And so with 2 satellites, we're able to measure the distance between the 2.
How far apart are these satellites, and just how precise do they have to have the knowledge of each other's position?
We have the satellites at 200 kilometers apart, but we're measuring down to an accuracy of a micron level, which is about 1/10 of a human hair.
That is extremely precise, but sounds like a very hard engineering problem. What's the technology that lets us do this?
We're using microwave technologies at about 30 gigahertz. Here you see one of the satellites, and 200 kilometers away is the other satellite. And what we're doing is we're firing an RF signal to the other satellite, and the other satellite's measuring that, and as you move backwards and forwards relative to the sine wave, you can measure the distance changes to the levels we need.
Neil, it's been well more than a decade since the original GRACE mission. I assume we're upgrading some of these technologies. Can you describe some of those?
Sure. Like technology advances in general, we've upgraded computer systems, we have more efficient solar cells, we have better star cameras, and like everything else in the future, we now have lasers.
Lasers, yes. What do lasers actually get for us?
So we're actually using the lasers to do the measurement between the two satellites. We're using RF systems from the previous missions. On top of that, we have this new technology demonstrator where we're going to fire laser beams between each other to make a more accurate measurement between the two satellites.
Neil, this is without a doubt one of the coolest missions we've seen. Thank you so much for answering our questions. When can we hope to see this launch?
So we're hoping to hitch a ride with SpaceX rocket later this year, and we should be collecting science data shortly after that.
All right, well, we'll certainly check that out. And everyone out there, check back soon for some more crazy engineering.
And we are looking at a gorgeous view of the rocket right now. Sammy, what is going on here?
Well, you see the rocket ready for launch, and right now what appears like smoke is actually liquid oxygen vapor, part of the fueling process that they go through for the Falcon 9. And there is what's called the strong back, which is the white structure right next to the rocket that actually helps hold the rocket in place right till the point of launch, and it will be pulled back right as we go through the countdown.
All right. Well, currently we're about just shy of 7 minutes from launch, but as we get closer and closer to these final minutes before launch, we'd like to take a moment for this message from NASA's new administrator, Jim Bridenstine.
While I'm sorry I can't be at Vandenberg today, it's my pleasure to welcome you all to another of NASA's amazing Earth science launches, the GRACE Follow-On mission to observe our planet's ever-changing water cycle, ice sheets, and crust. I want to thank the NASA and commercial teams that have gotten us to this point, and give a special shout out to the many scientists, engineers, and technicians who have worked years to make this mission possible. Your dedication is remarkable, and it truly is the kind of spirit that is carrying our space program to new heights all the time. Our philosophy on Mars has been to follow the water, and that has relevance right here on Earth as well. GRACE Follow-On data will provide unique insights into Earth's changing climate, and it will have far-reaching benefits to society, such as improving water resource management. Water is critical to every aspect of life on Earth, for health, for agriculture, and for maintaining our very way of life. This mission showcases a strong partnership between NASA and the German Research Center for Geosciences, while JPL manages the mission for NASA's Science Mission Directorate in Washington. I look forward to seeing many more Earth science missions during my tenure as NASA Administrator, and working closely with the team as we study my favorite planet, Earth.
All right, you are looking at a shot of the pad. We are just less than 5 minutes away from launch, and we are standing quiet to see how things go together. But as far as we know, things are a go.
We just received confirmation that fuel loading is now complete. So that's an excellent sign for preparation for launch.
All right, and conditions look fabulous.
Conditions look great. Weather report is excellent.
For strong back recheck.
Strong back will be start to be pulled back now. The strong back is what I described earlier as what helps hold the rocket up, preparation for launch.
Local bleed verification. And stage 1 locks close out.
Schombeck lower has closed out.
Rock, RC, countdown 1.
Rock,
Verify range is green and go for launch.
range is green.
Stage 2 locks load close out. Vehicle gas closeout started.
Ground gas close-up started.
AFTS is ready for launch.
F9 is in startup.
LD, go for launch. T-minus 30. 20.
Flight tanks configured for flight.
15. 10.
9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff of GRACE Follow-On, continuing the legacy of the GRACE mission of tracking the movement of water across our planet.
Vehicles pitching downrange.
Stage 1 props nominal. Nominal.
GC copies, we'll go. GC copies, we'll go.
All right, we have a liftoff, Frankie. And Sammy.
Power and telemetry nominal.
Beautiful launch. Falcon 9 is going up. We're going to have the first step is the max Q coming up in about 10 seconds. That's the point of maximum stress,
Falcon 9
mechanical stress on the launch vehicle. As it's going the atmosphere right here.
Vehicles experience maximum dynamic pressure.
So we just went through max Q. Everything's looking good. The next stage is the main engine cutoff. And main engine cutoff is in about 50 seconds. Main engine cutoff is the point where the first stage of the rocket will stop ignition, of course, and be deployed. You can see an image now from the rocket image, actually. So the main engine cutoff will be in 15 seconds.
Eco.
We have main
Stage
engine cutoff,
separation confirmed.
and stage separation has been confirmed. So the first stage was deployed. You can see an image from the second stage.
Impact ignition.
Stage 1 AFTS has saved.
So everything is nominal.
Fairing
See the
separation
fairing separation successfully. And you can see the GRACE Follow-On and the Iridium spacecraft in the picture there.
Stage 2 is following a nominal trajectory.
So everything's going nominal. It's an image of the second stage. So the second engine will burn for approximately 8 minutes. That will get the second stage and both the Iridium and GRACE Follow-On stack up to the point where GRACE Follow-On will be separated from that stack, and then the launch vehicle, the second stage, will continue on and deploy the Iridium satellites after another burn, actually.
All right. So we have 8 minutes until the second engine cutoff.
Correct.
So we're going to take some time to introduce folks to some of the members of the team. While we wait for the end of the engine burn, we thought we would be able to introduce you to some of the project managers, Phil Morton of JPL and German research project manager Frank Fleckner. They're both in the SpaceX control room at Vandenberg right now. They're monitoring this launch. But we did talk to them earlier about their roles and the stories they tell us about the relationship between the two teams. They tell us is a partnership that goes way back.
The data is available and needs to continue to be available. And how do you use it in a way that helps or benefits where you live specifically? Because you can really track right to where you live what the future might be like. There are tools now to monitor and estimate what the future might be like, given the trends that we see. I have the responsibility for the mission with NASA. That's sort of the way a project manager role is defined. So my responsibility is that the mission comes together and operates successfully. I have a counterpart, Dr. Frank Fleckner, who's at GFZ in Germany.
I was already the co-PI of the GRACE mission, and I became the GFZ project manager for all the German contributions to the mission.
He's a pleasure to work with. He's very knowledgeable on the science data from GRACE. We talk weekly, if not more. It's a pleasure to work with somebody that you can have a straight conversation with.
I know Phil already from the GRACE project from 98, 99. Say 6 years ago when we started to implement GRACE Follow-On, I was very happy to see Phil again to be the GPL GRACE Follow-On project manager, because I know him so long and it's easy to talk with him, and it's a really good friendship over the years.
We've taken the best of their expertise, combined it with the best of ours. You put these groups of people together, you want to make sure that we're all heading down the same path, heading towards the same goals. Everybody's working so closely together. We are seamless between the teams. It really has worked out well.
We are one GRACE family. We know each other since 1908, that's 20 years. Yeah. And so we all get older during the GRACE lifetime, and it's a great opportunity to run into a GRACE follow-on mission with many of these old friends.
So as we're standing by for the end of the second engine burn, the other things that we're focusing on is what happens after the second engine burn is done. What happens after that?
So the first thing that happens is that the GRACE follow-on satellites are separated. They're released from the multi-satellite dispenser.
And we have some video that we can actually show to
Sure.
illustrate what we're talking about.
So as you see here, this animation shows the GRACE follow-on 2 satellites being separated. The first thing we want to do is make communication and make sure that we have contact with the spacecraft. So they will release this S-band antenna that allows us to have communication. But the spacecraft at this stage are a little wobbly, I would say, so they would have to adjust. The internal propulsion system will make adjustments because we want the spacecraft to come in a what we call a safe mode, which points the solar arrays up to the sun and the antenna towards Earth. And that will take a few minutes, and then the first pass is going to be over McMurdo station in Antarctica.
So that is the first opportunity that we have communication with the satellite?
That is the first opportunity. We anticipate that we would have contact with both spacecraft at that point, but if that doesn't happen because of any delay in the stability of the spacecraft, then we have another opportunity in another 45 minutes.
What kind of communication are we talking about? Is it just a ping saying, I'm here, I'm alive?
We will actually get a health report from the spacecraft that tells us the power condition, the computer status, the communication condition, pretty much everything that we need to know about the health of the spacecraft at that point.
All right. So how far off are we from main engine cutoff then?
Main engine cutoff occurs in about looks like in about 9 minutes.
9 minutes, okay. So we are standing by.
Cook, LOS expected.
Tico.
Nominal parking orbit insertion.
Did we lose the feed from the launch vehicle?
So we are looking for second engine cutoff and a signal for second engine cutoff, and that's a critical period because that is when the satellites will be deployed.
Correct. The separation will occur right after main engine cutoff. Right after the main engine cutoff, we will be getting confirmation of separation from the launch vehicle, actually.
So you'll be hearing it from the team?
Correct. That they had successful separation. And then after that, in about 10 seconds, and then after that we will wait for establishing communications over McMurdo.
Will we be able to actually see the satellites deployed?
There's a good view, actually. We're hoping that we'll be able to get a glimpse of the GRACE follow-on
GRACE
satellite.
payload deployed confirmed.
The deployment of the GRACE follow-on spacecraft was deployed. That's confirmed, deployed successfully.
Fantastic. And you see the excitement in the rooms here.
Yes.
We could hear them.
Yes.
There they are. That is the EMOC at JPL.
Yeah.
We have folks here in the MDC, here at Vandenberg Air Force Base. So far, so good.
Excellent, excellent
Yeah.
performance. Now the second stage of the launch vehicle continues on to deploy the Iridium satellites.
It's got more work to do.
It does, and we wish them the best of luck for that.
All right, deployment of the 5 Iridium satellites.
Excellent partnership.
Vandenberg LOS expected.
So now we have to wait for the satellite, the GRACE Follow-On spacecraft to stabilize.
Uh-huh.
And I'm getting a message.
Okay. You're getting some communication?
It was another confirmation for the successful deployment.
So we have confirmation that both GRACE satellites have indeed been
Correct.
deployed.
Both GRACE Follow-On satellites or spacecraft were deployed successfully, and now the spacecraft will be stabilizing in their orbit. They'll be getting away from each other. That's natural movement that we intended for the spacecraft to do. Once the communication is established over McMurdo, we will know exactly what altitude they're in and what additional adjustments may need to take place. However, the spacecraft, in the mode that they come on, once they're released, they're in the safe mode. So the solar arrays face the sun, and the antenna faces Earth.
Okay. All right. So things are looking good.
Things are looking excellent.
Okay.
Throughout this period, we will have checkout of the spacecraft. So we'll go through internal checks on the spacecraft, and then once communication is established, we'll go through extensive checkout for the spacecraft, the conditioning and preparation for start of the instrumentation.
So it's going to be another 20 minutes or so before we expect to have that acquisition of signal when the spacecraft goes over McMurdo.
After separation, we have about 22 minutes actually to get signal, and that period lasts about 6 minutes over McMurdo, and we have to make contact with both spacecraft. And there is a period of time where we have to adjust the antenna, the ground antenna, to track the second spacecraft also.
All right. Next key moment.
Yes.
Well, can't wait. All right. Thanks, Sammy.
Sure.
We've been introducing you to members of the team, and here is another one, Hui Ying Wen. She's an MIT grad, an arts lover, and a JPL science applications engineer. She's part of the JPL team currently supporting the mission at the German Space Operations Center near Munich. We spoke to her in March about the work she's currently doing.
I work on spacecraft that measure how much water there is anywhere on the Earth. That's what it does in one sentence. Because water doesn't just disappear. If it's not on this part of the world, it probably moved somewhere else. So we're tracking to see where all the water is on the planet. This mission is so simple. It doesn't even matter whether they're satellites or rocks. All you do is just toss them so that they're in orbit around a planet. And if you can measure accurately the distance between them, I'm still amazed that we can do an extremely simple measurement like that and have it tell us so much. You really have to sort of interrogate your own morals and your own reasons for what you do, because it's pretty intensively impactful work in extremely different ways. It's not just about doing the math and doing the programming. Look at the data we're taking, right? We're assessing water levels. When you look at water levels, you can figure out where there are severe droughts. For us, it's just a little blip on a map of the Earth. But for someone who's living there or trying to farm or just live in that area, It's a blip that affects their entire life.
Joining us now is Deputy Project Scientist Felix Landerer of JPL. You know, listening to Hui Ying talk about what she does, and she expresses herself that, you know, what she does is not just looking at ones and zeros as you know, a person that's an engineer on a spacecraft. She sees herself as doing something that's really helping us understand our world. Do you feel that way too?
Absolutely. Just like the original GRACE mission did, GRACE Follow-On will continue to probe the Earth in a very unique way. You know, we're tracking very small distance changes between the two satellites, and that in turn allows us to measure surface mass changes, in particular those related to water, a very vital resource on the ground.
Give me an idea of what were some of the things that we discovered and realized before, you know, we didn't have GRACE, and now that we do have GRACE, what do we know now that we didn't know then?
Yeah, over the 15 years we had GRACE, we made a lot of very unique new measurements and got to reveal some of the largest mass changes. We already saw a few earlier, Greenland. Some of the biggest mass changes we measured are related to water over land, in particular over big aquifer systems. So, for example, here in California, and I think we have a small animation that we can roll right now, we measured how the change in water evolved over time, and we can see these increased water changes. Those are relatively wet years. Then we slide into multiple years of relatively dry climate, interrupted by a wet year where we see an increase. But then we also had this prolonged drought over a few years where we slid into this steep negative water storage anomaly. And with the GRACE satellites, we can really accurately track that water and inform decision makers how much groundwater is being pumped for agriculture.
So the whole point of having GRACE Follow-On come on the heels of GRACE is to keep that information flow coming. So when you think about it now, what next? I mean, where to from now? We've just launched. When do we get that science?
Yeah, so we're really trying hard to spin up our satellites to check out our instruments. So over the next few days, the satellites will drift into their final science configuration. Mm-hmm. They need to be 220 kilometers apart, so this will happen over the next few days. Okay. Then our engineers through the German Space Operations Center will one by one power up our instruments and check them out and make sure everything performs as intended. We'll do some calibrations, and in about 6 to 7 months from now, we're ready to release our first GRACE Follow-On data set.
6 to 7 months.
That's right.
Oh, wait, that's fantastic. Thanks, Felix.
My pleasure.
All right. Well, you may not realize this, but you can see GRACE and eventually GRACE Follow-On information on your own computer or mobile phone using a program developed by NASA's Jet Propulsion Laboratory. It's called Eyes on Earth, and with it, you can trace the movement of water around the globe using gravity maps from the GRACE satellites. All you need is the NASA EYES program, which requires just a one-time download. Take a look. All right, we have a successful launch and a successful deployment of our satellites. We are standing by now for the first communication with the GRACE Follow-On satellites, hopefully about 10 minutes from now. And that's when the satellites fly over the first ground station at McMurdo in the Antarctica. The station is part of NASA's near-Earth network of satellite tracking stations. It's sort of the Earth-observing satellite equivalent of NASA's Deep Space Network. When that signal comes down, it'll go to mission operations at the German Space Operations Center outside of Munich. That's GSOC, and that is where DLR Sebastian Lowe is standing by. Hi, Sebastian.
Hello to California.
Hello. So we are standing by for this very important acquisition of signal, and that's going to come into GSOC where you are, correct?
That's correct.
How does it all work? How will you be listening for this signal?
So we will have our first pass in McMurdo roughly in 10 minutes. This will be our first acquisition station. There is the ground station located. We will have the antenna pointed to the direction where the GRACE follow-ons will arise over the horizon. And as soon as they're there, they're hopefully transmitting a signal. And we will then record the signal, forward it through the ground station to DLR, GSOC, and then we will see it on our screens.
Now, there are two satellites. Do you anticipate that you will be able to get both satellites, an acquisition of signal from both?
That's the plan. So the first one will be GF1. We will use the first few minutes of the pass to get some telemetry from the first one, and then after a few minutes we will switch over to the second one, GF2, and hopefully after the end of the pass we saw both of them.
All right. If we don't hear from both of them, is that going to be any source of concern?
No, usually not, because at the moment we do not have real good injection information from SpaceX. We will only receive that 60 minutes after separation. So it just might be that the offset of the antenna is a little bit too much at the moment. And then afterwards we have another station, Spitzbergen. It's on the North Pole. Right after that there is another one over Alaska. And by that time we should already have a good orbit information from SpaceX, and then we should be able to find both of them.
All right. Well, we are very excited, and I'm sure you are too. All eyes are on GSOC now. Thanks for joining us, Sebastian. We spoke to another GSOC flight director, Kai Mueller, a few months ago while the team was undergoing one of their many operation readiness tests. That's something that they do quite a bit to prepare for a day like today.
Well, I've been working for the GRACE mission since early 2013, and it made perfect sense to keep on working for the GRACE Follow-On. We've now done the last simulation before the launch in the past couple of days, and we are ready to go. You can imagine we have quite a large number of people involved in such a mission. There's DLR performing operations for GFZ, the German Geoforschungszentrum. Then of course we have JPL, who are the project managers for NASA, partners from the University of Texas, who are the main scientists behind the project. And of course we have the partners from Airbus, who actually built the spacecraft. All of them have specific tasks that they want to see accomplished. And to coordinate this, you need someone, a point where everything comes together. I take all the inputs, which I then coordinate with the command operators to load and when to send out to the spacecraft. Everyone sits at exactly the place they're supposed to be, performs exactly the same task in exactly the same way we do it for the relaunch. We meet in a separate room to discuss what we've done. Did everything happen we expected to happen? Did we see any anomalies? And if so, we will discuss those and how to proceed. And then that repeats over and over again until we are through with our planned activities. I think it's going to be quite nerve-wracking. But I think once we're up, once we're in orbit, we're going to see the separation occur. I think then things are going to come down. In particular, once telemetry comes in, and that's...
All right, the first acquisition of signal is expected at about 1:20 Pacific time, so 20 minutes past the hour. We expect mission operations at GSOC will acquire that signal, and NASA will also be looking out for this signal. Folks here in the Mission Director Center here at Vandenberg are also keeping an eye out, and we are all listening. Sammy, explain to me what folks are doing right now, this acquisition of signal. How will folks here in the MDC know?
So we actually have a simulation that we have run and tracked with the spacecraft. So when we get signal, it's immediately fed into the simulation, and we'll get notification here that of the health of the spacecraft. And so as soon as the separation occurs, we will get that signal. But shortly we'll be looking at some of the simulation here to kind of describe how that occurs and over what period. But at this point, the spacecraft, as I mentioned before, is going through internal checks and stabilization. After the deployment of the antenna, the communication system is up within 4 minutes. Of course, the first thing that comes up is the computer system on board, and all the subsystems start powering up as a result from that. So everything so far, as far as we know, is nominal. We'll get the first signal from the spacecraft over McMurdo in Antarctica.
All right. Well, we'll be standing by. Sammy, while we are waiting for the acquisition of signal, I have a couple of social media questions that have come in. Maybe you can help us out here while we have time for you to answer some of them. From YouTube, from Space TV, a question comes in: how does the shape of GRACE help it do its job? The shape.
So the shape of the spacecraft actually was selected to be exactly the same as the original GRACE. And the original GRACE shape was selected to minimize the drag for the spacecraft in orbit. So that will result, of course, in efficiency in fuel consumption. So and the spacecraft lasted for 15 years, given that it was designed only to last for 3. But we were very efficient in the fuel consumption, and also, of course, the shape of the spacecraft made a big difference for that.
Okay. Here's a question from Jim on Twitter. Will the GRACE satellite passes be visible from Earth with the naked eye? Can we see
the spacecraft will be in their orbit, will be at 490 kilometers up. That's fairly high up for a naked eye. If one is extremely lucky and they have a very high-power binoculars or a good telescope, they may be able to see that. However, they'll be moving very fast, and it'll be very difficult to track them.
Okay. Here is another one from YouTube, Sparker. Can this method measure the absolute amount of water at the surface, or it can only measure the change of water distribution over time?
Yeah, this method actually is a change of water over time. So it's not an absolute measurement, and it's a relative measurement. We do this measurement every month, and we compare the results, and that's how we get an assessment or some knowledge of movement of mass, whether it's water or land mass, for example. But it's not an absolute measurement from this method.
Meantime, Sammy, we have the display that the team is watching right now. Can you explain this to the viewers?
Sure. So this is an animation, of course, and as I mentioned, the data is plugged in, so as soon as we get confirmation or communication with the spacecraft, we will get immediate confirmation that we have contact. So you can see here the spacecraft, both spacecraft are in a southerly trajectory, so they're going south towards the Antarctica, and they would pass the McMurdo station, and that's when we get contact with the spacecraft.
All right, well, I believe we're less than a minute away, so we're
very
going to stay
close, so
quiet.
we should be hearing confirmation very, very quickly.
Okay. We have here's clapping and applause in the room next to us, and the Skype signal I see from GSOC, I see applause there, so I understand we must have an acquisition of signal.
We just got confirmation that, actually I'm receiving it right now, that we have signal from FM2, spacecraft 2. So they're going through the cycle for confirmation. The data just came through in the simulation I was just telling you about. So they go through and make sure that they have the right confirmation. Still working through that.
And meantime, they have to reconfigure, hopefully to get the second satellite as well, right?
Correct. So as soon as that signal is completed on one spacecraft, they turn the antenna to point to the other spacecraft and get confirmation from that. So they received the telemetry from GF1, confirmation from GSOC now.
Fantastic.
So that's an excellent signal.
So let's go over there. Let's get the reaction over at GSOC right now. I understand Neil Daya is standing by right now via Skype. So we got a signal, hey?
Yes, we did. We got signals from what we call GRACE Follow-On, which is satellite 1. And if you can see behind me, you'll see on the center screen, on your left-hand side, it's got a green top, and you'll see a whole bunch of what we call telemetry information telling us battery state of charge, what the satellite is currently doing. And right now, it's in what we call real-time only mode, where it's sending all the data all the time, and we're just listening at it. But we're also trying to send commands as we go. So on the screen on the left and the right, you'll see a stack that's moving, and that's the commands that we're sending up, and also telemetry coming down from the satellite.
Are we talking about both satellites at this point, or just the first satellite?
Just the first one. If you look, you can see the green header is GRACE 1 and GRACE Follow-On, and that's the one that's running. And the left and the right screens are actually command stacks for those. We have not gotten satellite 2, but I don't know if we've transitioned. The plan was supposed to be for us to acquire and then me to come back up, but because of the delays and everything, we're doing this real time right now.
All right. And it would not be a surprise if you don't get it right away. You have another chance at it in 45 minutes, right?
Yes. I don't know where we're in the timeline because we've got a set 4-minute period where we're going to listen to GRACE 1, and only after that are we going to switch. Now, they both should have been in the same orbit plane, and they should be following each other. So the only thing the station has to do is to reconfigure for the different frequencies of satellite 2.
So how are folks feeling there?
I'm hoping that we actually get it
soon. I'm sure.
Sorry, go ahead.
You once have said, you know, your job is to make sure that you keep your satellite safe. And so it seems like that's exactly what you're doing right now.
Yes, right now this particular pass is a listen only, so we can get understanding of the stability and the health of the satellites. And if we need to do something right away, we can do it on the next pass. If everything looks good, then what we'll do is we already have a pre-scripted procedure of exactly what we're going to do and when we're going to do it, coordinated with the passes, and we'll just run along those.
All right. Well, the launch was here, but all eyes are on GSOC right now because pretty much all operations are going to be down your way now, right?
Yep, everything is going to run out of this location from here on out.
All right. Well, thanks, Neil. We'll be standing by. Meantime, that wraps things up here from Vandenberg Air Force Base. We did get the very first signal, so we know that we have acquisition of signal from the satellites. We may or may not get the second one on this pass, but worry not. We have an opportunity to get it on the next pass over the North Pole. But before we go, we want to give our thanks to our JPL crew that's at GSOC right now, Jim Round, Christopher Harris, and Kristen Weibold, plus the Kennedy Space Center TV crew who have helped us put this on for you. Without them, we wouldn't even be on the air. And of course, special thanks to Sammy Kayali, who helped us understand all the workings of this and this incredible mission. If you want to learn more about this mission, here is the website for you. It's www.nasa.gov/GraceFO. That's again, www.nasa.gov/GraceFO. All right, that's it for us now. Before we go, here's one last look at the launch and a salute to the people of GRACE Follow-On. Thank you, everyone, for joining us.
Ten,
9, 8, 7, 6, 5, 4, 3,